So now let me talk a little further about how we can choose a good working inside function. Because there will be times where choosing an inside function and then afterward recognizing the outside function can become challenging. And so before I start getting into this discussion right here, I have to mention one thing. There is no such thing as right or wrong choosing an inside function. So any expression can be regarded as an inside function. Okay? What really matters is how we can choose the inside function so that we can recognize easily the outside function, and further how we can choose an inside function so that the work can become effective. And because sometimes when we choose an inside function and it's a little too extreme, then it's going to turn out more work for us. And you will understand what I mean by that as I start getting into a few informal examples here. But so along with the first thing I was about to say, there's no such thing as a right or wrong inside function right here. So let me bring up a little example like this. So let's look at y equals x plus 1, and in parentheses x plus 1. Okay, and so there are no such thing as choosing what did I mean by there are no such thing as a right or wrong inside function, because really the idea, the main point of the inside function is just we can just simply pick any expression and think of that as it can be substituted away. And in that way right here, in a problem like this, we can substitute the x plus 1. We can substitute the x plus 1 right there for a variable u. That's one way. Okay? Or we can substitute the entire square root of x plus 1 for u. And that can also be an inside function. But now, and there can be a few other ways as well. The worst thing, the most extreme thing is you can substitute the whole x plus 1 times square root of x plus 1 to be your variable u. Okay? And so, but what I pointed out earlier is that none of these is wrong. What matters is how we make it work so that we can first thing recognize the outside function. And so with this substitution right here, if we let u equals x plus 1, then in regard to that as the inside, then here's what I'm seeing. Now if we choose this one right here, I also need to point out a couple mistakes right here that some of my students in the past quarter have faced. But this inside right here can be from that part inside the square root, or this x plus 1 can also be this x plus 1 inside the square root. So some of my students in the past quarter seeing this x plus 1 as being inside of parentheses. And so they come to the outside, they come to concluding the outside as the square root of x plus 1. I mean, it makes sense people think that way because this is inside parentheses and this is outside parentheses. So once we chose that to be the inside, then everything else outside the parentheses is called outside. But that's not the point of the inside and the outside. So that's not our criteria to look for outside, not simply because it's outside of a parentheses or outside of a square root. So along that way, then maybe somebody else can think of the outside as the x plus 1 in parentheses right here, because if we're treating this being inside the root, then outside of that root there is an x plus 1 expression, but none of these qualify to really be the outside function, because the real main aim now is that think about the substitution again. If we are substituting away the x plus 1, then our entire expression becomes what? This x plus 1 is substituted by u. The square root of x plus 1 is substituted by square root u. Now this final expression is entirely in terms of the new variable u only. No other additional x variable being involved. This is where you can say that this is where this is the correct outside function is. Okay? Because this function here being the outside function, every variable u and only the variable u now is being involved in this outside function. And so we can think about that as having x plus 1 being inside of each of these variable u. And that's the whole point. That's the whole thing about how you can correctly find. So there's still, back to the inside function, there's no right or wrong inside function, but what matters is from there how you can find the correct outside function to make things work. Okay? And so this is the outside function, and then we can have the advantage of turning that into a u to the 3/2 power. Okay? So that's one way. Now, when it comes to, so now let me put away this substitution. So that inside right there was good. What about if we choose this u equals square root of x plus 1? Again, I cannot judge that this is a wrong inside function to be chosen. I cannot say this is a right inside function to be chosen as the inside function. I can never make that judgment. What matters is, for anyone who chose this, how are we going to make this? How are we going to find the outside function out of that? Okay, so if we substituting this into the function, y equals, see, all that here now can be u, because it's a square root, the entire square root gets substituted away. Okay, but if you got hung up right here because there's still an x plus 1 that's still left behind, then we're not successful yet. Okay, so if anyone went that way, and like I said, at the step where you choose your when you're choosing your inside and inside function, there's no such thing as the wrong or right inside function. Anything can be chosen as an inside function. What matters here is that once you've made your decision to choose your inside function, how are you going to find the outside function to make it clear? Okay, so if we go this way and let u equal to this, then and then if you don't know, if you got stuck here in terms of how to get rid of that x plus 1, then we're going to say this is an unsuccessful one. But maybe, who knows, some other experienced mathematician can think of this x plus 1, see, it's all the algebra that get things to work. But x plus 1 here can be regarded as a square root of x plus 1 being square. Okay, and now with that square root here is another u right here. So this is u squared. So in the end, this x plus 1 can also be regarded as a u squared, okay, for the x plus 1, but times u. So now all of a sudden we found out it's working again. So it's not such a bad substitution. Any substitution is a substitution. Okay, so any substitution can be regarded as an inside function, and that's what I meant, because here I can successfully make another outside function completely in terms of u only, the new variable, and no more letter x involved. If anyone is stuck here, don't worry, pick another one. Okay, if anyone didn't recognize that we can go from here to here, that's okay. You can stop right there and stay away from this substitution, because if it's not giving you a recognizable outside function, then we can just stay, hey, leave that for somebody else, not for you. You know, use a different substitution. Okay, and so here with for some experienced people, then with stronger algebra background, and they can quickly see things like that, then for those people who recognize that, then this is also another working inside function. And so this is going to be u cubed y equals u cubed. Okay, and then for the last one, it's quite obvious, but so when we let u equal to others, all that here becomes your inside, then how does the outside function look like? Okay, so y equals u. Okay, so I just want to point out a couple of different ways of how we choose the inside function, and none of these is wrong. None of these is wrong. Okay, because like I said, as long as you know whatever you picked for being the inside function, as long as you know how to come out with the outside function. All right, but still, in this problem, let me point out. Let me move on to the other board right here. In the same problem right here, there's a working one and the working better choice of the inside function. So this is what I mean right here. So back to our beginning function, being x plus 1 times square root of x plus 1, for example. So now if we choose u equals x plus 1, okay, and for anyone who begin into studying calculus, I recommend that you take as much different ways as possible, as many different ways as possible, experiments for yourself as well. Okay, so now if we're going with this x plus 1 to be chosen as the inside, then the outside function is now clearly, okay, y equals that becomes a u. This is the square root of u, and now in other words we're looking at u to the 3/2 power, because this is power 1, this is power 1/2, so 1 plus 1/2 is power 3/2. And so finding the derivative now, let's see how well this can help us here. Derivative, as we've learned throughout example 1, and let me stick with, since I kind of going in this direct substitution, let me stay with that the style where I write the dy du and the du dx right there. Derivative of the outside is a 3/2 times u. Now 3/2 minus 1 is a positive 1/2. Okay, and times, and now right from here I'm looking at a du dx here can simply be just 1. Okay, so I'm going to multiply that with 1. Okay, and so that means my final expression now is going to be 3/2 times, see, the u now is just simply bring back its original meaning. Okay. So it didn't cost too much at all, and any of these derivative steps are quite easy. Any of the derivative steps, inside and outside, they're both working pretty good. So I put good check mark, red check mark, indicating that the derivative steps in any of these are pretty easy to do. Okay, easy to do. So that's one of them, same function. But now what if we chose u to equal the square root of x plus 1 here? Okay, then yes, we can immediately, and as I said, even for the students who are, or for the people doing math, doing calculus who are experienced, and can find out that once we chose this to become u, then our outside function, once we chose this to be the inside, I meant, okay, if this is the inside, there's no right or wrong inside function. Anything you can choose to be the inside. Okay, but so now, and with experienced people, they can rewrite this as, see, the square root of u plus square root of x plus 1 is a u. But this here, in my argument earlier, we can write that as a u square. Okay, so u square times u is a u cubed. Okay, so y equals u cubed, and completely washed away the x variable. So now we're good with that outside function. So when it comes to the derivative, dy dx, of course we need the dy du multiply with du dx. But see, think about it. This the dy du is easy. 3u squared. 3u squared, and we will bring back the original meaning of the u. But now, what about the du dx? Is it easy to find the derivative out of this? Or, I mean, at this point, maybe we have learned some using chain rule again, so probably we have to find another inside out of that. And so that means if we're choosing the inside function this way, then we're going to end up doing another chain rule over here. Okay? And so my point now generally is it's not easy. Getting this derivative is not easy compared to the earlier one. And so it will work, it can work, but I'm not patient enough to go through all the way to the end. So this one here, I can tell getting this derivative immediately is not as easy as the earlier choice right there. And so now it will work, but it's not working as well as the earlier choice right there. And then the one that, and we can also choose a u to be x plus 1, the whole function itself to be a variable u. So x plus 1 times x plus 1 in square root right here. So if we choose that extreme, take the whole package and putting that into one variable, well, and we call this the inside. Again, as I said, there is no such thing as a right or wrong inside function. Any function, any expression can be chosen as the inside function. And so now here's how the outside would become. The outside would become y equals, all that here is now a u, so y equals u. Okay, so derivative, chain rule says the derivative dy dx is going to need dy du, this coming out pretty easily, multiply with the du dx. Okay, but now the dy du here is just simply the derivative of this is 1. Okay, but the du dx here is, I'm so sorry, but this is the exact, we're just exactly repeating the exact same problem from the beginning. We didn't get us anywhere else. Okay, so this is another problem where we're just repeating our problem. Okay, to find du dx right here, right? It's just the same as the earlier problem. So did that get us anywhere? No, we haven't got anywhere. Okay, and so this is I'm saying that this is for now a not working so well choice, right? Because you're gonna pretty much repeat the whole loop and along the way invent a different inside right there. Okay, and so we will never make judge on the inside. Any inside can work, and once you chose your inside, then make sure you create derive your outside function accordingly, but then make sure you choose your inside in a way such that when you're taking your derivative of the inside and the outside about equal level of ease. Okay, equal level of being easy. Okay, and so along that way, let me bring up another quick little problem. All right, so back to my other board, I still remember back in example, if we were looking back to example 1 part D right here, and our problem there, maybe I might be off by the coefficient or something, but it should look just like the one we've close enough to the one we had back in the example 1 part D right here. But we had a function like this. Okay, so y equals, how about I went with the -10 over, and then it was a 2x to the 5th power plus 4, and we raised that to some 4th power maybe. Okay, so, and like I said, maybe I'm off by a couple of coefficients or something like that along the way here, but the idea here is this function is quite similar to our example 1 part D right here. So here's the thing. So back in my work, and I chose u to equals 2x to the 5th plus 4. And throughout the entire example 1, I was asking viewers to to take my experience, to take whatever I deliver as from my own experience. But now think about it. One day when you are doing your own problem right here, don't be nervous about how you choose a U. I chose that. You can choose something else different. If it works better, faster for you, that works. Okay? But so, for example, this problem, now I chose this to be my inside. And so my outside became, if you recall from example 1, my outside became y equals negative 10 over u to the 4th power. Okay? So this is, once again, a good checkpoint is once we substitute away the entire, what we call the inside function, then everything else remains only in terms of the u variable, the new external variable. And in that way, we can call this now the outside function. And this outside function here is negative 10 u to the negative 4th power. And so, in that way, when I took the derivative, so in my work getting the derivative dy dx, I need the dy du was dy du multiplied with the du dx. And think about this. The dy du was quite easy to get. Negative, actually just altogether become 40, positive 40 u to the negative 5. And then when it comes to multiplying with the derivative of the inside, because that was now our outside function. Okay? So deciding your outside function comes straight out from how you decide your inside, and then just make sure that your outside looks completely, has completely no x variable left. All the x variable got washed away. But now with this outside function, taking the derivative of the outside function is quite easy. And so, and now the du dx is also quite simple, quite straightforward. 2x to the 5th plus 4 is now going to give me the derivative 10x to the 4th. Okay, and that's how we're done. Okay, and we can just now simply substitute back this original meaning of the u variable. So 40 times 2x to the 5th plus 4 to the negative 5 power and times 10x to the 4th. We're good to go with that. Okay, so it was easy. It's easy to find this one, and it's also quite easy, quite direct to find that one. Okay, but if we chose, so after our video lecture here on the chain rule, I want viewers, I want any one of you who study with me, explore on your own about, and trust me, your experience will take you there. And as the more you work with your own problems, the faster you get in terms of choosing the inside. So the same function. Now I switch board, but the same function. I could have chosen u to equal the entire 2x to the 5th plus 4 to the 4th power. Who's telling me that I'm wrong? No one. Okay. There's no judgment about how you choose your inside. Once you choose this, your outside function, here's how it looks. Y equals your entire, if we chose it that way, then our entire function here, but the whole package in the denominator now becomes u. Okay, and so that means your entire function now in terms of u is just simply negative 10 over u. And so we can rewrite that as a negative 10u. Okay, so the outside function looks simple enough, but now let's get to the derivative steps here. Inside, no judgment, no right or wrong, anything can work as long as you can find an outside function out of that. But now, is this a working well one? That's what we want to find out next. Okay, dy dx, the chain rule says find the derivative of the outside, which is negative 10, simple enough. I shouldn't rush here, but how about once again, let me lay down the step. I need a dy du, the derivative of the outside. Okay, so just that. Multiply with the derivative of the inside, du dx. And so dy du is quite simple, as I said, negative 10 as a constant being left behind, but I need to multiply Now that here, things are not as easily laid down as in the earlier case right here. So if I do something like this, if I find the du dx out of this, is this that easy anymore? Okay, we're gonna eventually, you're gonna start thinking about when you handling this problem separately, you're gonna start thinking about substituting this 2x plus 5, 2x to the 5th plus 4 away and consider that as a new inside. And so I'm not saying that this cannot be done. I'm not saying that this cannot be done, but not as easy. You see what I'm saying? So on the outside function, it's pretty easy to find the derivative of the outside, but then the derivative of the inside that you chose didn't come out as easy. So why going this route? It takes too much work, right? It takes too much steps. And so that's why here, this one here is the better choice. The better choice. I'm just saying the working better choice for being the inside function. All right, and so now at this point, after hopefully a thorough enough discussion here, then I'm going to take everyone into our example 2 to see how we can apply the chain rule further. And so now I'm going to really start picking up pace right here. And so this lecture that we're at really comes after the lecture I talked about how to find the derivative of trig function. But see, if you're now looking back at that, the lecture I've had about finding the derivative of trig function, the trig functions we were working with there were really basic, quite basic. Not too much can be done with that. But now, after we've learned and have seen some examples with the chain rule, how the chain rule is going into action, okay, then let me now bring in, and like I said in the beginning of the lecture here, be aware that even if, even after this lecture, be aware that chain rule exists and lives again in other kinds of derivative problem. All right, so always keep your eyes open for the chain rule. Let's call this now example 2. Okay, same instruction right here. Let's find the derivative of any given function here, or simply the dy dx thingy. Okay, so that's the symbol for it. Now, my first function here is part A. All right, so I'm going to start being a little bit skippy in the steps, in the way I'm presenting. But after thoroughly seeing through example 1, then anyone should be able to get a good hang of it. Now, my function here is y equals to, how about sine of 2x? So, in my lecture for trig function, we actually had an example very similar to this. I don't remember if I did an exactly the same or something like this, but it's a double angle inside of our trig function. Okay, so now without the chain rule, we can still solve this problem. Without the chain rule, we can still solve for this problem. So quickly, let me make a note right here. See, without, if really anyone who doesn't want to use the chain rule, then we can still have a way to get around with this. So without chain rule, then the same problem can be re-expressed as y equals, see, we're going to have to remember some trig identity right here. Sine of a double angle is the same as 2 sine of x times cosine of x. And so really, if anyone doesn't like to use a chain rule and decide to go to find the derivative of this function without chain rule, then one way we can do, I'm not saying that this is the only other way, but one way we can go is re-expressing that sine of a double angle as a product, constant coefficient, and sine times cosine of x. And so in that way, our derivative is ready. dy dx equals 2, and now, well, because it's a constant coefficient, we can simply keep it there. Derivative of sine is a cosine, so it's cosine of x times the other function, the same product rule that I'm using right here. That is just the product rule. Plus, and now I'm going to keep sine of x the same, okay, but I'm going to multiply with negative sine of x. This is the derivative of our cosine function. Okay, so all together in the end, this is, and that is a cosine square, this is a sine square, okay, but minus sine square, so all together my derivative here is 2 cosine square of x minus 2 sine square. Sine square of x. Okay, so we can still find the derivative completely without the chain rule by rewriting this as a product of sine and cosine with a coefficient 2. So without a chain rule, one of the way is to recall your understanding about trig function. But now how do we find the derivative of this function by using the chain rule? And that's my intention of the whole lecture here. And so now allow me to erase that other solution. So the solution that we applied the chain rule. Okay, so let's go ahead and pick the inside and outside again. But this one here is obvious enough. And again, after my earlier discussion about choosing an inside, there's no such thing as a right or wrong. So just feel free to pick. Okay, but in my experience, I would pick this one, okay, the part where being obviously inside of our sine function. Okay, so now I'm gonna start labeling it. So inside, and we are at example 2 and almost ending with our lecture here. But for anyone right now at this instance viewing this video, then you are assumingly the beginners to doing this. So I highly recommend that you label out the inside and the outside function. But trust me, one day when you're at a teacher's level, a professor's level, you don't have to do this anymore. I mean, when I'm doing this on my own, I never have to label the inside and the outside. It comes pretty trivial. And so inside here is a 2x, and even allow me to just simply write the expression without worrying about doing the substitution. Okay, and now the outside function, right, is just or how about, I shouldn't let anyone into the bad habit, so how about my personal choice, I prefer to go with g of x is the inside regarding to all that as a function. So 2x is my inside. Okay, and my outside here, see, if we hiding this 2x away, then sine is now the outside function, sine of something. Sine of something. Okay, and that something here being hidden away, you can think of that as some other variable x right here. So f of x is sine of x. So this whole function sine of 2x comes out from f of g inside of it. Okay, and so in that way now, so our derivative dy dx according to the chain rule, it says we need f prime of g of x multiplied with g prime of x. Okay, and so f prime of g of x is, see, the outer function, the outside function is sine. So when you take the derivative, it's going to be cosine, but leaving 2x inside, because this is the derivative of this is f prime at evaluated at g of x. And now I need to multiply with g prime. So with g right here, g prime is simply 2. So this is going to be in a little bit more simplified version, 2 times cosine of 2x. So we got our derivative. Wait a minute, does this look like the answer we've had in the other solution? It doesn't, but it is the same. Recall for yourself with a trig identity that recall for yourself that cosine of a double angle 2x is cosine squared of x minus sine squared of x. And now since we have a 2 here, then our expression would just multiply the 2 then with the 2 here. So in the end, this is the answer we found in the earlier solution, and this is the answer we have just found now. They are the same answer. Okay, and so that's how we are doing part A of our example 1 right here. And this time the chain rule applies directly here. All right, and so now I'm going to take some time erasing the board and let's look at another problem in our example 2 here. All right, so how about y equals cosine square of x? Okay, so in the world of trigonometry, I just need to remind anyone about trigonometry, but in the world of trigonometry, function, a cosine square or a sine square or a trig function square and then the x. This means it's just the way how we understand it correctly, so that we can do our work, effectively. But cosine squared of x means we're looking at cosine of x, then square. Okay, and now after I wrote this down in this way right here, then all of a sudden it's a lot easier to recognize the inside. But in the end, so how I choose my inside here is not the only way. You might choose a better way of finding your inside. You might have a better way of finding your inside, and it works even better than mine. Go for it. I highly recommend any of my students to become creative. Okay, so I'm going to go with g of x as my inside being cosine of x. See, the cosine of x as a function being inside of that square. Okay, and so that's my, and once again for anyone viewing this video being the starter into studying calculus, then yes, I label out the inside. One day, that day will come when you're fluent enough, then you don't have to even label that anymore, and these things just gonna come pretty much on the go right there, on the fly. That's what I meant. Okay, and so once we chose that, then if we hide away that inside function we are already chosen, then the outside is just something square, right? So f of x equals x squared. Okay, and we can regard to this as the outside function. Okay, and so once again, quickly double check right here. I don't always do this, but it's trig functions. It could be tricky sometimes. See, so the whole function here is your whole y function really is your f putting g inside. See, because see, x squared, but now for the x we put the cosine, the g function in the x right there, and that's how we ending up with square, but then cosine of x being square. It's just a quick double check, or in other words, the function f is being composed by the function g. All right, but then so now we are ready for finding the derivative. All right, so dy dx, the chain rule says we need to find f prime evaluated at g, okay, and multiply with g prime. All right, and so in that way, everything is pretty laid out for us. F prime need to go first. So f prime is the simple power rule. So 2 times, so basically it should be 2 times x, but keep in mind x now is being substituted by your function g right here. So that x here, I'm going to leave that there kind of empty, and now I'm filling in the cosine of x. So 2 cosine of x. Okay, but we're not done. We need to now multiply with the derivative of the inside. The inside function here is cosine of x. So derivative of cosine is negative sine of x. Okay, so all together, and now I'm ready for my other board and getting directly to our final answer. So final dy dx here in our case must be minus 2 cosine of x times sine of x, and we're done. Okay, that's how we apply the chain rule into doing another problem that involves trig function and some other function inside of it. Okay. All right, and so now let's come to our part C of the example over here. And so now I'm looking at y equals cosine of x squared minus 3x. Okay, and so I am going to pick, for this problem, I am going to pick, even though, as I said again, there are no right or wrong, the inside and out, inside the function to pick. Okay, x squared minus 3x x squared minus 3x, I can regard to this as some g of x. Okay, and this is my inside function. All right, and once I have chosen that, then think about the whole thing here reads cosine of x squared minus 3x. So now if I'm hiding away that, because I already substituted that away, so if I'm hiding away that inside that I caught, then it's cosine of something. So cosine of something. So that means f of x here is outside is a cosine of x function. See, cosine of something, cosine of some x expression. So this is outside. Okay. All right. And so the derivative dy dx. Chain rule says I need to find f prime evaluated at g, and then multiply with g prime of x. Okay, but f prime, the outside function is cosine. So f prime of, or the prime of cosine is simply what? That's negative sine up. But now instead of x, I'm going to leave that big wide open ready for substituting in the g of x. So g of x is the x squared minus 3x. I'm going to put that in my parentheses here, x squared minus 3x. Okay, and then I'm going to multiply with the derivative of the inside. So g prime is quite simple from here, and any of these steps is quite simple in terms of getting the derivative. So now it's going to be 2x minus 3. Okay, and that is our final answer without taking us too much cost of effort.